Recording in 3, 2, 1. Decreasing development costs and improving time to market. These are the two main challenges of electronics design. We need to get the product out the door as quickly as possible and as cheap as possible, meeting market demands without jeopardizing product quality. So what are the challenges in doing this? There is a disconnect between the EDA, or electronic design automation tools. Schematic capture is done typically in one package and the layout is done in another. The design will go through many iterations and it's likely the data will go out of sync. Engineers are constantly looking for components, data sheets, and supplier information. More than 50% of engineering time is spent doing component research instead of designing. Now add the mechanical design to the mix. They're on another CAD platform. It doesn't talk to the electrical software, and collaboration is usually done through exchanging emails, sticky notes, and exporting files. Sounds like a headache. In PCB design, 1, 2, even 4 iterations are common. According to the Aberdeen Group, the cost of one prototype averages $8,900. That's potentially $3,600 just in prototyping. Customers need an integrated solution that will help solve this cross-domain problem. That's SOLIDWORKS PCB. So what does SOLIDWORKS PCB do? Here's what you need to remember. Schematic capture tied to real-time component supply chain information. PCB layout with intelligent interactive routing and comprehensive design rule checking. 3D visualization with real-time clearance checking and collision detection. Seamless integration with SOLIDWORKS, native data exchange that's always in sync, as well as integration with electrical and the remainder of the SOLIDWORKS ecosystem. Let's have a look at SOLIDWORKS PCB. I've broken it down into 4 primary categories: the collaboration tools between SOLIDWORKS PCB and SOLIDWORKS, the schematic capture tools, the PCB layout tools, and the deliverables coming from SOLIDWORKS PCB. We'll start off in collaboration. We'll see how the board shape, component layout can be created and defined between SOLIDWORKS PCB and SOLIDWORKS, as well as how the two tools communicate between each other. I'll start off in SOLIDWORKS PCB, where I've got a schematic that's been started in my project here. I have a USB jack, a couple of LEDs, an SD card jack, and an HDMI jack. All of these have been set up initially, and I have an initial board that's been created. Within SOLIDWORKS PCB, you can see that I've got a panel that allows me to both push and pull the board information. When I push, I can define what the initial board is and push that information along with that board shape over to my colleagues. All this information is stored and time-stamped, indicating who has made the changes and when those changes occur. Over on the SOLIDWORKS side then, we have our initial enclosure that we're working with. If I look into this enclosure, I can see that I have a basic shape from which we're going to work with. In SOLIDWORKS PCB, with the add-in, we can go ahead and pull the board or create a new board from either existing projects or create new projects. Here I'll just go ahead and use the existing board and define the initial board assembly based on what was sent over from SOLIDWORKS PCB. Already I can see the changes that have occurred. Now that I have this board, it's just a matter of going back in and inserting it into our enclosure using a standard SOLIDWORKS tools to set up mates and define where components are. I'll just go ahead and create an initial mate, and I'll fix it even though it could be defined as you like. Now it's just a matter of coming in here and editing the sketch for this profile. I don't need the default shape, So let's go ahead and change that out to a shape that I've already created as a starting point. So with that board profile, we'll go ahead and define the shape, giving us initial shape of the board profile based on our enclosure. Now we have this initial enclosure that's been put together, and we can go ahead and push that change back over to SOLIDWORKS PCB. All the while, we're keeping track of what the changes are between the two products. Switching back over to SOLIDWORKS PCB, we can now see that there are changes that have been made to the board shape. We can see what those changes are and choose to accept or not accept those changes. So this gives us an initial board based on the shape of the enclosure. I'm ready to now take those initial components and import them from my schematic. The nice thing about SOLIDWORKS PCB is I capture what items need to come over from the schematic and place them onto our PCB layout. I'll go ahead and execute those changes, and equally I can save a copy of those changes so that I can go back and refer to them as I need to as my design progresses. Now that I have those, it's just a matter of placing the components onto our board in such a way that we can start to work with the board. You'll note that SOLIDWORKS PCB provides automatic collision detection as we add components onto the board, giving us great visual feedback as we're placing these components. So we'll go ahead and place this last component, and we'll finish with our USB jack. Now that it's a clear location, but I'm going to put it over here so we can have an idea about exactly some of the things that we've got available to us. Go ahead and push that content over and post the comments back to the device. Again, we're getting a running commentary of the changes that are occurring between the two systems. Now it's just a matter of pulling those changes over, and we can see that SOLIDWORKS the PCB connector allows us to see the changes that have been added to our project. Not only that, but it's giving us nice feedback as to where those changes are. I'm going to go ahead and accept all of those so that we have our initial board put together. As I said, this USB jack is a little bit out of place. So let's go ahead and move that. Again, I could use mating or such to place the component as I need to, move it around to fit it in place, and then leave it as such. So this gives us the starting point for our board, and if we go back to SOLIDWORKS, we can see that that board is in place. Perhaps we could affect some changes to our HDMI port, but we'll go ahead and leave it as it is for the time being. So now we've made those changes, it's just a matter of moved USB to make that comment so that we know what has happened on the other side. Again, coming back to SOLIDWORKS PCB, we can see what those changes are. We get an idea about where they're occurring, and make a choice to accept or deny those changes. So this gives us a nice way of getting feedback to and from. I'm operating within my own environment, and I'm not having to go out and save out a separate file format and make those conversions separately. I know I've got the file that's in sync as I need it. So we've just had a look at how we can use SOLIDWORKS PCB and the SOLIDWORKS PCB connector to collaborate on the board shape creation, the component layout, and communicating information back and forth. Let's have a look at the schematic capture portion. Here we'll have a look at the circuit design capabilities, our supplier links, how we might manage our libraries, as well as some design rule checks within SOLIDWORKS PCB. I want to move forward a little bit into our project. Now I've added some additional components and circuits into our project. If we zoom in on our project a little bit, we can have a look at some of the areas that we have available to us. Along with your standard definition of nets and connectivity between components, we have the ability to move off sheet and set up a multi-sheet schematic capture within SOLIDWORKS PCB. Moving around through our schematic, we can see the ability of using adding annotations and information to our project, whether it be creation of components, schematics, or otherwise. Here I will just go ahead and finish the next steps of this particular tool. As I add, I'm using the next components within that particular multi-part symbol. Looking at the information gives me indication of what the designator will be, as well as what footprints, if I have multiples, if I want to add additional footprints or other information, as well as what kinds of pins are available on this particular component. I'll leave that alone and go ahead and place our wires. All of the information is readily available at our fingertips from the context menu. Wires are easily drawn into our schematics, and information is captured directly as I draw my wires. All of this is easily captured as I build up my schematic. We can see other areas of capabilities that we have within SOLIDWORKS PCB. Equally, we can, as we look through our system, we can capture all of the information or see what's available on a given selected component. I'm going to go ahead and add in the MCU for this particular project. And we'll go ahead and capture the first part of that particular component. Selecting on it has information that's been captured from the library, including information with respect to its description, information saved within the library. Now if I want to have up-to-date information, I can go to our supplier links and look at tools and search online for information related to that particular component. So I can find the information directly from my supplier, whether it be Newark, Farnell, DigiKey, and so on. Searching for the appropriate component gives me just the right component that I'm looking for, as well as access to its data sheets, availability and pricing, and so, as well as additional information associated with that component. So this information is readily captured within that component for our bills of materials. As we build up all of the information and the contents to the links, we have access to our supplier link, as well as what the reference information is for that particular component. Now looking at the project, we can define information as far as what the connections are going to be, how we generate our classes, and define rules on what's going to happen when we check and compile this particular project. So with circuit design, schematic capture gives us access to circuit design, supplier links, library management, and design rule checks are built in as we build up our schematic. Now let's have a look at the PCB layout within SOLIDWORKS PCB. We'll have a look at how we can place components, how we can route to those components, and how the design rule checks can help us with routing as well as validating our final project. So let's have a look at our project at this point. I've started to route a number of components. I've put them into place, and it's just now a matter of working within our system. Looking at the top of our board, we have some space where we can add some additional components. I've already created a number of components for this project, but all I want to do, because I'm only working on a subset of those, we'll just go ahead and add in a couple of components based around a particular circuit. And what we can see here is that those components have now been added to our circuit, and it's just a matter of bringing them in and placing them into our circuit. Now that we have this, we can take advantage of our interactive routing, where we can see SOLIDWORKS PCB gives us some nice tools for routing directly to the various components, including adjusting the routing size based on the adjustments that are necessary for the board. As we move forward, we have capabilities of creating the differential pair routing. Here we'll go ahead and begin our route. And naturally, as we get closer to this BGA, our routes are not going to fit. So let's go ahead and adjust based on our design rules to a different size that allows us to fit the rule. The last area that we have for routing is the ability to set up a multi-route, pre-selecting a number of paths and routing from those paths. Gives us some nice tools for pulling together and adjusting the shape of the route in order to help with exactly where those components would be, and then finish up the route as we go forward with it. Now, with any system, we'd like to be able to show the board. It's just a matter of creating a polygon from different areas, setting up exactly where that polygon pour is going to occur, and define what net it's going to apply to. Here I'll create a ground net and set it to be poured. Looking at this, we can see that the pour has been set up based on our rules that we've set within the design rules. So SOLIDWORKS PCB gives us access to placing our components, routing with intelligence, and allowing online design rule checks to occur as we're developing our PCB layout. Now that we have our information pulled together, we're going to have a look at our deliverables in the form of our bill of material, our manufacturing information, as well as our assembly drawings. So let's have a look at how that pulls together. In SOLIDWORKS PCB, naturally we'll want to have our bill of material. So opening up our bill of materials is just simply a matter of clicking on the file and opening up our active bill of material. Here we see a number of columns that we can add to as far as electronic information, manufacturers, electronic information, and so on. Because we've added a link to our suppliers, we can obtain the manufacturer, his part number, as well as the quantity that we're looking for, as well as the individual pricing for that component. So this gives us great real-time information and feedback for our bill of materials. Now that we have this, it's just a matter of saving it out to a template or saving it out to a spreadsheet. At the same time, you have tools that allow us to generate our Gerber files, defining what layers we want to have for those files. If we want to use an ODB++ generation, and so on. If we're looking for our drill files, we can go ahead and include a drill table that has information associated with our board. Looking in at it, we can see exactly how many holes we have and what sizes of those holes we have with respect to our board. Now all this information is being saved onto our sheet. If we go ahead and show that sheet, we can see we have information as far as manufacturer information for the build, as far as notes are concerned, to go back to our suppliers, and so on. This gives us a lot of really good information as far as working with our output. We can go through the process of setting up our pick and place, as well as setting up assembly drawings for our overall project. Here we can see the drawings that are ready to be sent off as PDF files or as drawing files. So we've had a look at some of the deliverables that are available to us within SOLIDWORKS PCB. We've looked at the collaborative tools that allow us to communicate between SOLIDWORKS PCB and SOLIDWORKS. We've been able to see how the schematic capture helps us to define what that overall board will look like, what the PCB layout as far as how the traces can be put in, and the ECO reporting that's going back and forth between the schematic capture and the PCB layout. Finally, all of our deliverables that we need to send off to manufacturer are readily available for us. So let's come back to this. PCB design and layout is all done in one environment. We've been able to work with real-time supplier links to help us with real-time cost and availability. Electrical and mechanical exchanges natively and is always in sync. SOLIDWORKS PCB will help not only with reducing the number of prototype iterations, but the cost of software is actually less than a typical prototype.